Good morning, class. Coach Day. Today's video is going to go over the graphing of quadratic functions. I know we've kind of had a quick turnaround. We just finished system of equations, but we are going to have to get into new stuff because we don't have a lot of time left this year. Now, a quadratic equation looks like this. You're going to have y equals ax squared plus bx plus c. So it's a number, x squared, plus another number x, plus whatever regular number. The function, remember, if you see it in function notation, we just change out y for f of x. So it'll be f of x is equal to ax squared plus bx plus c. Now remember, a function has input values called the domain. And remember, the domain, that's our x values. And output values called the range, and those are going to be our y values. The graph, so the quadratic function produces a graph that is called a parabola. It's going to look like it's going to look like a U. All right? Now, here's how we can graph a parabola. We can take the equation, we can plug in values for x, and get values for y, and then plot points. So, let's start out with -3. Well, if I plug in -3 for x, I get y is equal to -3, and that's squared minus 4. -3 times -3 is positive 9. 9 minus 4 is just 5. So the y value would be 5. If I plugged in -2, y is equal to -2 squared minus 4. That's going to be -2 times -2, which is positive 4. 4 minus 4 is 0. If I plugged in -1, I would get y is equal to -1 squared minus 4. That's going to be positive 1 minus 4, which is -3. And then when I plug in 0 for x, y is equal to 0 squared minus 4. That'll just be -4. Now, something interesting about parabolas is they're going to repeat and mirror each other. Watch what happens when I plug in a positive 1. One squared is 1. 1 minus 4 is -3. When I plug in 2, two squared is 4. 4 minus 4 is 0. When I plug in 3, 3 squared is 9. 9 minus 4 is 5. And you can see that we had mirrored results with the same number, regardless if it was positive or negative. So let's go ahead and graph this. Let's get -3, 5, -1, 2, 3, positive 1, 2, 3, 4, 5. -2, 0, so -1, 2, 0. -1, -3, -1, -1, 2, 3. 0, -4, 1, 2, 3, 4. 1, -3, so over 1 down 3. 2, 0, over 2, up and down 0, and then 3, 5, over 3, up, 1, 2, 3, 4, 5. Now, when we connect the dots, this is our parabola. It's going to go kind of like this. And that arrow means it keeps going. And this side is going to be a mirrored image. Now, what we're going to do is label some of the points. A vertex is where the parabola reaches a maximum or a minimum. I'm sorry, I was reading the definitions, but you guys couldn't see it. A vertex is where the parabola reaches a max or a min. It does reach a minimum right here. So this little dot right there, that's our vertex. The axis of symmetry is one part of the parabola over the other. An abbreviation for axis of symmetry you might want to know is AOS. And really, it's just the middle part where you can fold one part over the other. So we'll just call this the middle. So on this line, the middle part that I could fold one side over on top of the other is right here. It goes through our vertex, and it splits our parabola in half. So right there, goes through the vertex. If I folded this side on top of the other, it would land perfectly. I'm going to stop the video here. We're going to do another video with the rest of the notes.